Today I'll be demonstrating how to prove that root 2 is irrational. So we're going to be using an algebraic approach for this. So the way we approach it is we will start by giving a counter argument. So we'll say root 2 is irrational. And we'll do that by saying root 2 can be represented by a over b, where a over b have no common factors. We can then expand this b across, multiply both sides by b, but to make it quicker, we can square both sides. So we can square root 2 to give us 2, and we can square both of these. We can square that fraction to give us a squared over b squared. What we can then do is we can then expand out that over here to give us 2b squared is equal to a squared. Now this tells us that a is even. Right, now what we can do, if a is even, we can say 2b squared is equal to an even number. Now what we usually do for an even number is we represent it as just 2n squared. So we've changed a into 2n to represent a even number because it has a factor of 2. Then we can expand this out by giving us 4n squared. Now we can divide both sides by 2, giving us b squared is equal to 2n squared. Now, what does this mean? Well, this means that b squared is even, therefore b is also even. Now, we've now established that a is even and b is even, so therefore a is even and b is even. So they have a common factor. Therefore, proving, or shall I say disproving, my counter argument, which is that they can be represented by a fraction of a over b, where a and b both have no common factors. So I've just established then that a and b must have a common factor of 2, therefore root 2 is and must be irrational.